Okay, hi everyone, and welcome back to my channel A in Economist. I hope you guys are doing well. Firstly, thank you so much for showing your love and support in my previous work. I hope I am adding value in your life. So, now let's start with today's session. Today, it is going to be our fourth lesson on time series analysis. In the previous sessions, we were discussing about modeling a time series process, so in which we have completed what is a classical approach of modeling time series, and in the previous video I have talked about what is the stochastic approach of modeling time series, right? Now we will continue with the stochastic process, and we will learn a very crucial topic today, which is the stationarity of a time series. So in this lesson I will explain to you what is stationarity as a concept, and I'll also talk about how do you detect stationarity and what are the different types of stationarity. Now, stationarity is one of the most crucial and fundamental topics in understanding time series analysis because it helps you in modeling time series, and it has several other implications also that I'll be discussing. So, let's start with understanding the concept of stationarity. A time series process YT is said to be a stationary process if the process is in a particular state of statistical equilibrium. Now, what do we mean by statistical equilibrium is that in the intuitive sense, stationarity means that the statistical properties of a process which generates a time series do not change over time. Now, if you watched my previous video, then you will know what are the statistical properties that we are interested in while we are studying the stochastic approach of time series, right? If you haven't watched that video, I would recommend you to go to that video first and then come back to this video. So for revision, I am saying what are the statistical properties that we are interested. The first property is the arithmetic mean, the expected value, that is the unconditional mean of the time series process YT, right? This is the first property that we have talked about in details. Then the second property is the variance of YT, right? Variability of YT. And the third property is the autocovariance. Autocovariance of autocovariance of YT and suppose YT minus H, where H is some non-zero scalar, right? So we are interested in analyzing the autocovariance between YT and some lag value of YT. So these are the three statistical properties that defines any stochastic process, right? That we have talked about. Again, if you haven't watched that video, I will give the link in the description. You can check that out. So what is stationarity? So in intuitive sense, what we have studied is that stationarity means the statistical properties, that is in terms of mean, variance and autocovariance of a process that generates time series do not change over time. So the statistical properties will be unchanged throughout the timeline. So if you start with t equals to 0 and you go to t equals to say 10, then any time point in between you study the process, the properties, these properties will be the same. This property will not change. And that is the statistical equilibrium, right? That is what is statistical equilibrium. We will understand this using diagrams and all, so that will give you more clarity on this. As of now, just understand it does not mean that the time series does not change over time, just that the way it changes does not change itself over time. So you can take a screenshot of this, or you can understand this by yourself, that it does not mean the time series does not change over time. Time series will change over time, but the way it changes, that does not changes over time. And that is what is the concept of stationarity. Now let's understand this with the help of this diagram. So in this axis, we have the time t. So we are measuring the time in in the interval 0 to 1000. So you can assume any units. It could be minutes, it could be seconds and all. So any units you consider. So this is the timeline that we are considering, and here you have the values of the process YT, and this is the process, right? This is the value of yt over time, t from 0 to 1000, right? The process looks like this. Now, by looking at this process, you can understand something. Firstly, you can understand what will be the mean of this process. What is the expected value of yt? If you look closely, see there are some positive values over 0 and there are some negative values over 0. So what will happen is that these positives and negative values will be averaged out and the expected value will be simply 0. This I hope you know from your statistics concepts also, that this positives and negatives value will be averaged out and this is the average value, right? This is the average value. The average value, expected value of this process is simply 0. And what does this tells you? This tells you that this expected value is independent. This expected value is independent of t, that is the time. Since this expected value is 0, which is a constant, so this is independent of t. What does this mean? Suppose you consider a time point 100. This will be in the middle of somewhere, right? Here. So if you consider mean of this process yt at this time point 100, then what you see? The expected value will be 0. Expected value of y at the period 100 is 0. Now, suppose you consider another time point 800. At this time point, what you will see? The expected value of y at the time point 800 is also 0, right? So for all t, for any t you consider from 0 to 1000, the expected value does not change over time, right? At any time point, you can do this for any time point. So for any time point, this expected value will be unchanged, right? And this is the first property of stationarity, that the expected value do not change over time. So if you see this process again, you will see the process itself is changing, right? So it sometimes it goes up, sometimes it goes down, and then it follows this path, right? So the process itself is changing, but the way it is changing is unchanged, right? Here also the mean is 100, here also the mean is 0, and here also the mean is 0, and any point in between you consider, the mean will always be 0. So the expected value is independent of time, and this is the first property of stationarity that you can understand from this diagram. Okay, now what about the variance? What will happen if you consider the variance? So again, see this diagram closely, you will see that all the values of this process varies between -5 to +5. So if you say, yeah, some values are more than -5. So approximately if you consider all the values of this process, all the values of this process lies between this line and this line, right? And this is the mean value. So what you can say, variance is always considered keeping in mind the mean. So if you start from this point, the value of the process can either go to this 5 units, it can either vary to this side or it can vary to this side, and the variability will always be in this 10 units, right? 0 to 5 and 0 to 5. So what you can say here is that variance of yt is also a constant value, say sigma square. Suppose sigma square, right? Variability of this process, variability is considered from mean. So value, the expected, so variance is what? Variance is expectation yt minus expectation yt whole square, right? This is the variance. So you are taking the distance of the individual value of this process from its expected value. So that will be 5, right? This from this side to this side, this is 5. From this side to this side, this is 5. So in general, variance will be some value sigma square for all t, which is also a constant, which is also a constant, which is also independent of time. Variance is also independent of time. So what I am saying is that suppose you consider this 100 time point, here you have some variance, and suppose you consider 600 time point and here you have some variance. So that variance will be the same. The variability here, the variability at this time point will be same as the variability at this time point, right? The variability will be unchanged over time. Variability will be a constant which is unchanged over time, and this is the second property of checking stationarity, that the statistical property is unchanged over this entire timeline. The mean is also unchanged. The variability, here also the process varies between -5 to +5. Here also the process varies between -5 to +5. Here also the process varies between -5 to +5. So over the entire time point, time period, or the time range, timeline, whatever you want to call it, the variability will always be the same, that is constant. Now we don't know what is the value. For that we need to have the specific time points, have the specific value of the process yt. Yeah, I hope you got the process. And the third thing is the autocovariance, which we all also write as this gamma th. So if this way autocovariance depends on t, you will write gamma th, otherwise you will write it simply gamma h, right? So here again, what you see is that every error term is independent of each other. So you don't know, if you start from this point, you don't know what will be the value in the next time point. The error terms that you will commit at every time point are completely independent of each other, right? The error terms that you will commit at every time point is completely independent of each other. So the autocovariance that you will get will be some constant value, some scalar value which is also independent of t, some fixed value which will be independent of t, right? There is no uh, the autocorrelation does not depend on, the autocorrelation is present, but it does not depend on the timeline, right? So these are the three things that I want to discuss with you using this diagram, that the mean, the variance, and the autocovariance all will be independent of t, and that is what we have discussed here, that the statistical properties, that is the statistical properties of the process generating the time series do not change over time, right? They will not change over time. I hope this is clear. And the series, it does not mean that the series is not changing. Here you can clearly see the series is changing, right? It has variations in this way. So the series is changing, but the way it changes does not change over time. I hope this is absolutely clear to you, right? Okay. Now moving on, next what I have given you is the difference between stationary process and the non-stationary process, right? Here you see in this diagram, so here for both the diagrams, on this axis you are measuring the time, and on this axis you are measuring the value of the process, right? Suppose this is yt. So for stationary process, as I have told you, the process is this. So the variability is from this to this. So you can consider a range of variability, and the mean will be somewhere around this, right? So mean will be at this value and the variability will be from this range to this range. So again, the mean is independent of time, the variability is independent of time, and the autocovariance is also independent of time. So clearly you can understand this is a stationary time series process. Now, how do you detect non-stationary time series? Consider this time series. Here what you see, what will be the mean? Just think about this. What will be the mean of this time series? The mean of this process will be in the form AT, where this A is greater than 0. So it will be some scalar value A which is positive, and the mean is completely varying over the time point, right? Mean is varying with the time. So if you consider a time point T1 here, the value of the process is this. If you consider T2, the value of the process will be this, and if you consider t3, the value of the process will be this. So as you increase the time point, what you will see is that the mean, so it will be here, the mean will be a into t1, here the mean will be a into t2, and here the mean will be a into t3. So as you increase the value of t, the average value will also go up, right? From the diagram itself you understand this, that as and when you increase the time point, your expected value of the process is also increasing. So expected value is very much dependent on time. In case of non-stationary time series processes, the again the opposite is true, right? Expected value or the variance or the autocovariance or all three will be very much dependent on time. So here to detect the non-stationary process, you don't have to put in so much labor, because just by looking at the mean, you know the value is dependent on time, and hence the process is non-stationary. If it so happens that the expected value is independent of time but the variance is dependent, suppose, on time, then also it will be non-stationary. If only the auto covariance is dependent upon time, then it will be also non-stationary. And if all three are dependent on time, or any two are dependent on time, then also, if any of the feature is dependent on time, you will characterize the time series process as non-time series, non-stationary time series, right? Okay. And this is again the same thing. This is the stationary time series. You have some specific range of variability. You have independent error terms. And here also you see this is the mean value. The mean. Here the variability is constant. Variability is following some specific range, right? So variance is independent of t, but the mean itself is dependent upon the time point, and hence the process is non-stationary, right? I hope this is clear to you. Now the most crucial question here to understand is, why do we at all need to understand stationarity? What is the benefit of understanding the concept of stationarity? Okay, so now we will understand this in detail, that why stationarity is very crucial as a concept and why do we at all need this. The answer is on the diagram only that I have shown you. The first point that I have given you is the predictive consistency. Stationary data has constant statistical properties over time, making it easier to predict and model future values based on the past patterns. This you can directly understand from the diagram I have shown you. So suppose you consider this diagram, and here you have considered up to 1000 time points, right? What if you want to check for 2000 time points, right? Here you have only 0 to 1000, and you know this is the pattern, that the mean is 0, the variability is this to this, and the autocovariance is some constant value. Now you want to predict, or you need to forecast. You need to predict or you need to forecast what will be the value of the time series, or what will be the nature of the time series. So what will be the nature of the time series at this 2000 time point, right? So simply what you will do, you will observe these characteristics and you will replicate that characteristics. So while modeling or while forecasting the process for the next 1000 time points, right? From suppose from 1000 to say 2000. So you are considering this timeline now. So for modeling this or for predicting this or forecasting this, what you simply do, you will replicate this characteristics that you have for the previous years or for the previous time points, right? What you observe from 0 to 1000 time point will be replicated for 1000 to 2000 time point. So here also you will model the time series in this way, that from 1000 to 2000 time point also the mean will be continuous. This will be same as 0. You will have a constant variance and the autocovariance will be independent of time. So this is how predictive consistency is being maintained if the data is stationary. So whenever you have a non-stationary data, the first task you always have to do is to make it stationary, because without stationarity you cannot model a time series. I hope you guys understand this. This is very crucial to understand, that if stationarity is not maintained, if your data is not stationary, then you cannot model or you cannot predict a time series. Even if you have the original dataset that you have collected is non-stationary in nature, the first task of you to analyze the data is to convert it into a stationary data. And how do you do it? I will be making videos on that in some future time, right? So as of now, just understand that in order to maintain predictive consistency, since we have fixed statistical properties over time, it is easier to predict and the model, and it will model the future values based on the past patterns. Whatever you observe in the past data, you will predict the future in a similar way, right? If you have any questions further on this, you can ask me in the comment section, right? Okay, the second point is statistical inference validity. Many statistical model assumes stationarity. It is absolutely fundamental. You have to assume stationarity before going into any statistical analysis on time series data, allowing reliable inference and ensuring the test statistic t-test f-test follow standard distribution. So I'll be making videos on inferential statistics also, but if you have knowledge of inferential statistics, you will know what is t-test, what is f-test, and in order to derive any meaningful inference from the statistical data, from this time series data, you have to assume stationarity. And the reason is again the same, because if you have stationarity, then only the statistical methods will be valid. Your inference, what you have drawn from the data, will be valid only if your data is a stationary data. So again, I am repeating the same thing again and again, that even if your data set is non-stationary, you have to convert this first, because then only you can predict, you can use the data set in some productive way. You can predict what will be the future values. You can validly carry out the statistical inferences, and you can apply this t-test f-test also, and they will follow some standard distributions, right? The third thing is simplified modeling. Stationary series often requires simpler models that we will see in our future videos. What are the specific models that we will be doing? It will be moving average method, it will be white noise and autoregressive methods and processes. We'll be talking about them. Since the data is not subject to systematic trends and changing variance, reducing model complexity, improving the interpretability. So you can take a screenshot of this, and I have some more points to you for you, and you can again take a screenshot. They are the same thing. Okay, just for completeness, I am reading this out, that improved parameter estimation. Once you can carry out inferential statistics in a valid way, parameter estimation also becomes easy. You can test the hypothesis, you can, forecast things easier in a easier way, and you can also improve your parameter estimation. Parameter estimation from the historical data available, providing consistent, meaningful insights across different time intervals. You can forecast it accurately. Models on stationary data are more accurate in forecasting because less prone to overfitting trends and non-constant volatility, which can distort predictions. Easier comparison. Stationary series can be compared directly. So if you have seen my absolute introductory video of time series, I have told you that comparison is one of the main tasks of time series analysis, right? You want to compare between different processes over time, so that you can derive some meaningful conclusions out of that. So stationarity helps you in doing that comparison. Comparison of the series can be done directly, allowing analysis across different time points, variables, without needing adjustment and of trends and variance changes, because they are already independent of time. So you don't need to make any further adjustments on that. And the seventh point is detection of the true relationships. That is, with stationarity, the underlying relationships, it could be correlation. Relationships like correlation are more likely to be genuine rather than artifacts of trends and seasonality, making the conclusion of causality more reliable, right? More reliable. So these are the 7 points that I wanted to mention. But the main point is this, that predictive consistency is maintained. If you know what are the definite pattern or definite properties of your time series in certain time point, you can use that as your reference, and then you can predict the future. You can make forecasts and predictions depending on that, and we will see that the past patterns will be repeated, the past patterns will be replicated while modeling the future, while predicting the future, or while forecasting the future. And that is the main importance of this stationarity property. If you have certain properties, if your time series has certain specific properties, then you can use these properties. If this was the case, that suppose this time series starts from here and this goes like this, and then it never comes down, it only goes up and up and up. So you don't know what will be the what will be the property in this time point. So there is there is no certainty what will be the values in this time point. So forecasting is not possible in this case, right? So for that, if you have this specific kind of a pattern here, the pattern is random. This pattern is completely random in nature. You don't know what will be the value, but you know that these properties will be satisfied. You exactly don't know that if your process will come, go up here and then come down here. You exactly don't know what will happen, but you know the average will be zero. You know that the variability will be somewhere between this. So this will help you in modeling your time series. I hope this is absolutely clear. Now in the next video, I'll be going into the types of stationarity. I will be discussing what is weak stationarity and what is strong stationarity, and what are the interrelations between them, and how do you solve questions around this, right? So stay tuned for the next lecture. I hope you find this video helpful. If you find this helpful, then give me a like and do subscribe to this channel, A N Economist, and I'll be coming back to you with a new video on types of stationarity. Thank you for your time.